Alright, so the other thing you need to do for this lab is to make a bar graph. To start with, you need to have calculated your mean and your standard error for each piece of equipment as was shown in the previous video. Now in this case I have just labeled my devices A, B, and C, but in your case you're going to have an actual piece of equipment for each of these. So you'll have 3 means and there are 3 standard errors. We need to start by setting up our axes. Make sure that you have your axis that is large enough to include all of your values. And then you'll notice I just have 3 spots here for piece of equipment A, B, and C. Always label your axes. In this case, we've measured our mass. So we measured out the mass in grams of each sample. And then down here, simply the equipment used, telling us that that's what we used for each measurement. The next thing we need to do then is put in our bars. And so what we want to do is we'll start with device A here. Our mean value is our big solid bar. So it's going to start at 23.88. That's where our mean is. So we would go over to our graph, draw in a line at 23.88, and then connect it all the way down to 0. Something like that. We would do the same thing for devices B and C. So in this case, 24.71 would give us a line right around here. Connect that down. And then for C, 26.33. So it would give us a line right around here. And we would connect that down. So that would give us our bars, which are our means. Next, we have to add in a standard error. Our standard error is plus or minus the standard error from our mean. So our mean plus or minus that is where we think our values fall. So we have to add in a standard error. In the case of device A, it's going to be plus 0.854 and minus 0.854. So what we want to do is draw in a smaller line, 0.854 above our mean and below, and then connect them. So if we want to go above our mean, we need to draw in a line at 24.37, so right around here, and draw in a line at 23.02, which would be right around here, and then we connect them into an error bar. Over on B, our standard error is 0.088. So again, we would go 0.088 above and 0.088 below our mean. In this case, that means we would go up to 24.8, which doesn't really get us very high above that line, and down to 24.6, and so our error bar looks something like that. For device C, we have a much larger standard error. We go 1.225 above our mean and 1.225 below our mean. So we would have one line up at 27.55 and one down at 25.1, and our error bar would look something like that. Now that's all fine, but all of this space in here is wasted. And I say it's wasted because we don't have anything that's different between our 3 different pieces of equipment. So they're showing the same exact thing for all of that space. What we would like to be able to do is show more of a focus on what's going on up here. What we can do then is redo our y-axis, so this axis over here. And the way that we can do it is getting rid of that entire area that wasn't providing us with any difference between our samples. Now, if you do that, one of the things that we need to do is indicate that we've chopped off part of our graph. And so what we traditionally do is draw in 2 little diagonal lines there to indicate that we've cut off the bottom. Now we do the same exact thing we did before, but notice how much more spread out our values might be. So if we look over here, 23.88, well, now we can actually put a line at 23.88. It makes it a little easier. Connect our bar there. 24.71, so over here, draw in our bar. And 26.33, and we draw in that bar. Again, plus or minus our standard error. So up to 24.7, down to 23.0, and you'll notice how much larger that looks in comparison to the previous graph. For B, 0.088, well, we're going to go up 0.088, down 0.088. It's a little bigger, it's not huge, but it's definitely more detailed than in our last one. And for C, we stretch all the way up to 27.55 and down to 25.1, giving us a much larger error bar in this case. So now when we look at this, we can see the definite differences between these, especially if all of our error bars had been a little bit closer in size. So this is what I'm going to want you to do for your assignment, is to make a bar graph that looks somewhat like this.